Okay, Assalamualaikum. Physics Form 5, Chapter Force and Motion 2, Title 151 Resultant Force. Okay. So, Force and Motion, Part 2. Okay. So, the first topic is Resultant Force. Okay, so what is our learning standards? So, today we are going to discuss two learning standards. The first one is describe resultant force. Secondly is to determine the resultant force. Okay. Now, look at this picture. Two participants are competing on a tug of war competition. Tarik tali kan. Okay, so we have participant A apply a force FA to the left, and we have participant B apply force FB to the right. Okay, so this FA, this FB, and here is the flag. Okay. Now, what determines whether the flag tied to the rope is at rest, move to the left, or move to the right? In other words, who is the winner in this competition? So it depends on what we call resultant force. So it depends on which side has the bigger force X on the on this competition. Okay. Now, to begin, we have a first activity to generate idea of resultant force and to determine its direction. Okay, we have a very simple tug and war competition. Okay, we have a wooden block. We have a spring balance A and spring balance B. Alright, so we pull the wooden block using spring balance A and spring balance B in opposite direction so that the wooden block does not move. Okay. Second round, we do the same thing, but this time we want to make sure that the block will move either to the right or to the left. Okay, so each step we will look at the reading of the spring balance. Okay, so here is what we should get. Okay, when stationary, both have the same reading. Let's say 5 Newton. Here is also 5 Newton. But it will, when you move to the right, so on the right side, B is on the right side, right? So the force is bigger, 10, and here is 5. When you move to the left, here is 10, here is 5. Now here is you should look at the difference. 5 and 5, the difference is what? 0, right? 5 tu 5, 0 kan, kosong. This one is what? Which one is bigger? So to the right is bigger. So what is the value of the difference? So 10 minus 5 is what? 5 Newton, right? This one 10 minus 5 is what? 5 Newton. But this one is to the left, this one is to the right. Okay, so let us discuss what we have here. Okay, compare the reading of both spring balance when the wooden block at rest, stationary. So when the stationary, it should be the same. So let's say 5 Newton, here is also 5 Newton. So the resultant force is equals to 0. As a result, the wooden block is stationary. Now, move to the right means which one? B should be bigger than A. That's why it's now 10. This one is 5. So 10 minus 5 is what? 5 Newton to the right. So B must be larger than A. Okay, next we have we want to move to the left. So A must be bigger than B. Let's say 10. This is 5. 10 minus 5 is what? 5 Newton. Right. So as a result, state the relationship between the direction of movement of the block and the direction of the force X on the wooden block, so that the wooden block move in the direction same with the larger force. If you want to move the block to the right, so the force to the right must be bigger than to the force to the left. So the wooden block move in the direction same with the larger force. Okay. So this is the first conclusion. Okay, so when two forces of the same magnitude acting in opposite direction, okay, applied on a stationary object, the object remain at rest. So seri lah. Okay, tak siapa menang kan. But if you have two opposing force, different magnitude, okay, so this one is who is the winner? Okay, B, the blue is the winner, right? So B has a higher X pull with higher force than B. Sorry, the red one. This one, the red one is bigger force, so he is the winner, right? So because he pulls with the larger force to the left. Okay, so what is the meaning of resultant force? So resultant force is the single force that represents the sum of two or more forces acting on an object. Again, a single force. It is the single force that represent the vector sum ataupun the sum of two or more forces acting on an object. For example, here is a car. We have two forces acted. So here is 100 Newton. Here is 50 Newton. So what is the difference? Means that what is the sum? So 100 minus 50. Why minus? Because 50 is in opposite direction, right? Always opposite direction. So 100 minus 50 is 50 Newton. Okay. So resultant force equals to 50 Newton to the right. Okay. Okay. Now direction of the car is to the right. Okay. Now let's look at the next learning standard is to determine the resultant force. After we understand the resultant force, now we want to determine the resultant force produced when two forces are acting on an object. So in this case, we will sum with two forces. But how they are summed, there are four situations that we are going to discuss. So the first situation is the two forces acting on an object on a plane. Okay, with the same direction. Okay, same direction. So we have the two force, 5 meter and 12 meter. So calculate a resultant force. Which direction does the object move? So 5 to the right, 12 to the right. So same direction. So we add up 12 plus 5 equals to 17 Newton. As a result, the object will move to the right. Definitely it will move to the right. Okay. Next, we have a hose pulling with 500 Newton. The farmer helped the hose by pushing the cart with 200 Newton force. So what is the resultant force? So 500 to the right plus 200 to the right also equals to 700. So the cart will move to the right, definitely. Okay. Alright, now we have in opposite direction. Okay. Two forces acts on the same object with opposite direction, means 12 Newton to the right, 5 Newton to the left. So remember, we add up to sum. So 12 minus 5. Why minus? Because opposite direction means to the left. So that's what 12 minus 5 equals to 7 Newton. 7 Newton is positive, means that the object will move to the right. Okay. Okay. Alright, now we have 500 Newton, the hose, but the farmer do not want the hose to the right, so it will pull opposite direction, 200 Newton. 500 Newton force to the right, but the farmer pull to the left. So what happened? Who will wins? So 500 by the hose and 200 opposite direction to the left, so we put minus. So 500 minus 200 is what? 300 Newton. So as the result, the hose will win, the hose will move to the right. Okay. Now, we have the next one is situation 3. Two forces that act on an object perpendicular to each other. Okay, how we are going to solve the problem? Okay, so we cannot add up 6 plus 8 equals to 14 Newton or 8 minus 6 is 2 Newton. No. So we have the method what we call a parallelogram method. So how we do that? Okay, first we complete the diagram representing the two forces that are perpendicular to each other. Okay, so this is a complete rectangle, and then we draw a rectangle that represent the resultant force. We draw the diagonal. Diagonal is what? From this side to this one. So we have two diagonal, right? From here to here or from here to here. So we choose what? 6 Newton, 8 Newton in between here. So this is the diagonal. And what we do is we calculate by using a Pythagoras system. Pythagoras theorem, that is what? 8 square plus 6 square, square root and 10 Newton. Actually, this is 6, 8, 10, 3, 4, 5, right? So theorem Pythagoras. Okay, next we have to calculate the angle, because we want to know the resultant force in which direction. So normally we measure the angle. So we can calculate by using sin, cos, tangent, right? So in this case, this is 8, 10. This is the theta that we want to know, calculate. So I use cos theta equals to 8 divided by 10. Okay, adjacent divided by hypotenuse, right? So 8 divided by 0.8. So theta is 36.9 degree. So what we can say is the direction of the resultant force is 36.9 degree from east, this is the east, right? Or from x coordinate, x axis, whatever lah. Okay. Alright, so this is the third situation. Okay, now the fourth situation is we still have the two force. This one. So this is the two force. So we pull here. What happened? This will move in a direction. You think which direction? So it will move to the right, right? So pull a block with forces of different magnitude and direction. Observe the effect of the combination of the two forces on the block. Okay. So two block move to the right. Okay, the block will move to the right. Not in this direction or this direction, but it will go straight. Right? Okay. So now we will learn two methods of determine the resultant force. The first one that we did just now is parallelogram of forces method, and the second one is a triangle of forces method. It's very simple, just follow the direction. Okay, so we look at the first one, parallelogram method. So we still have the two forces, 6 Newton, 8 Newton, and here we have perpendicular to each other, 90 degrees, right? So the first step is you have to complete the rectangle. Okay, right? Remember, this is always parallel here. This is also parallel. Next, we draw a diagonal here, right, from the middle of the two forces, right? So we can use this one, Pythagoras theorem, or we will learn next. You measure the distance between the two this line. Okay, the next one is triangle method. Triangle method is actually part of parallelogram methods. Okay, so what we do is we start with okay, this is F, resultant force. So we start with 0, 0.0, and then we choose, let's say we want to start with 6 Newton. Okay, so this is the 6 Newton. And then we want to sum with the 8 Newton. So this time 8 Newton we put here. Okay. Alright. So what is the resultant force? It's from 0 to the end of the 8 Newton. The beginning of 6 Newton to the end of the 8 Newton. Dia berturut-turut lah. Dia punya arrow tu kan. So macam tu. Next. So this is the resultant force. Or we can start from O is 8 Newton. Okay, so we start with O. So the beginning of O. So this is the 8 Newton. Then we add up with 6 Newton. Okay, here. And we get here, right? So this is the end of the 6 Newton. So the diagonal is from 0 to here. So this is also the resultant force. Nampak tak? Look at, this is the parallelogram, right? So triangle method is half of the parallelogram method. Okay, so now let's move to how we determine the parallelogram method. Okay, now we have to draw. Okay, because it's difficult to calculate. You also can solve this problem by calculation, but the best method is by drawing. So when you draw, you need to have a scale. So in this case, this is 1000 Newton, 2000 Newton. So we use a very reliable scale. I use 1 cm equals to 200 Newton. Okay. So what you do is, first, using ruler and protractor, draw the two forces F1 and F2 from a point. Okay, let's say this is the point. So point O. Okay, let's say I want to start with F1. Okay, F1 is what? 1000 Newton, right? So we have to draw how many? How long? So I have 1 cm 200. So if 1000, so I have to draw for 5 centimeter. Okay, let's say this direction. Just follow this direction. So I use a ruler. So this is 5 centimeter. So I stop, right? Okay, so this is P, point P. Okay, so here is the 1000 meter equals to 5 cm. Okay. Okay. Next, we have to add with the second force F2. So remember, this is parallelogram method. So we have to start with 0 here, the point 0. Okay, so here we have the angle between the two forces is 60 degrees. So you have to use a protector to measure 60 degrees. So I use a protector here. Okay, so measure 60 degree. So what is the 60 degree? So like 60 degree. Okay, next we want to know how long. So it's 2000 means 10 centimeter. So I use a ruler. Make sure it is what, 10 centimeter. So I use this is point Q. So label it as 2000 meter, right? Now we have to complete the parallelogram. Oh, this is difficult, but you have the method, right? So what I do is, okay, so I add a line here. Okay, now I want to have this one, right? So we know that this is the angle is 60 degree. So what I do is I use a protector and I measure 60 degree here. Okay, and this should be 5 centimeter. Use a ruler, it should be 5 centimeter. Okay, and then we have another one. Okay, so what I do is I draw a line here and put a protector there, and then draw at 60 degree. Here is 60, but now it's really touch the line here, right? So this is the complete parallelogram. Now the next step is to draw the diagonal, right? So diagonal, which diagonal that we want to draw, definitely this is the one, right? So in between 1000 meter and 2000 meter. So take a ruler and draw straight to this point R. Okay, this is F. Okay, now you use a ruler to measure the distance. So I have here is 13.2 centimeter. So what we do is 32 centimeter times 200 meter is the scale just now, right? So I get the answer 2640 Newton. Okay, this is for the resultant force. Means that this is the force which pull the ship. The force comes from the two towboat, and they will combine to get 2640 Newton. So the ship will move in this direction. So this direction. So this is the direction of the movement of the ship. Alright. Okay, you can use another method. That is a triangle method. Okay, so the scale is still the same. Okay, so I start with 0 here. Same thing. So I want to choose F1. Okay, so measure 5 cm. Okay, correct, 5 cm. Okay, point P. So level it. Now this is the second one is F2. If I put here, it will be the parallelogram method. So remember the end of P. So use okay, we have another line here. Okay, so use a protector, measure 60 degree. Because both F1 and F2, they are separated with an angle of 60 degree. That's what we measure here, 60 degree. Okay, so how long? So use a ruler. So it should be 10 cm. Remember, 2000 Newton equals to 10 cm. Okay. And lastly, we want to draw the resultant force. So what is the resultant force? From the beginning of F1 to the end of F2. So that will be the diagonal which represent the resultant force. How long is it? What is the value of the resultant force? So take a ruler and you have to measure. So we measure 13.2. Oh, same with the one that we use parallelogram method, right? So we have the value is 13.2 cm times 200, we get 2640 Newton. Same thing. Okay. Okay, I hope you understand the step. So we pause, we stop here. I want you to finish the module. Okay, and do the two problem just now. Okay, do on your own to get the answer. Please check is it same with me or not. Okay, and then do the exercise. Exercise 1, I think you have 4 questions to answer regarding the topic that we have discussed just now. Okay, see you. Thank you very much.